Hello and welcome back to another episode of Math with Son. Today we're going to be doing some division of polynomials. Specifically, we're going to be avoiding the long division. That'll be a different video. We're going to do something called synthetic division and then just simply dividing by a monomial. Okay? So when you have a singular thing on the bottom of the fraction, or if you're dividing by a singular thing, and what I mean by that is there's no minuses or pluses. See how here we have an x plus 3? Whereas on this one, we have just 2x to the third and a y to the fifth. No pluses in between the x to the third and y to the fifth or anything like that. This one, what you can do is just divide everything individually. You can just do 12x to the sixth, y to the fourth, divided by the 2x to the third, y to the fifth. And you can keep writing that. You can do minus the 5x to the seventh, y to the y, over 2x to the third, y to the fifth. Okay, and you can write all three terms out. Hopefully I can fit them in. 2x to the third, y to the fifth, over 2x to the third, y to the fifth. And then you just divide them all individually. Okay, so when we divide them individually, remember that we divide the numbers just like we would. 12 divided by 3 is 6. And then you find the difference between 6 and 3, and the bigger number will get that value. So the difference between 6 and 3 is 3, and the bigger one's on the top. But the difference between 4 and 5 is 1, and the bigger one's on the bottom. So that's why the 1 is on the bottom. Now 5 doesn't divide by 2, so we're just going to write minus 5 over 2. The difference between x to the seventh and x to the third is 4, so this is going to be x to the fourth, and the 7 was bigger. That's why we have the 4 there. And then the difference between y to the first and y to the fifth is 4 as well, but the 5 is bigger, so that is where my y ends up. And then the last one, this is a 2 over 2 is 1, and x to the third and x to the third is 1, and y to the fifth and y to the fifth is like 1. So this is just 1 when we divide it, and you might be thinking like, well, wait a minute, the difference is 0. Well, anything to the 0 power is 1. So this would just be written as a 1 when it's all said and done. Okay? Now, the next problem we're doing is the exact same thing. It's just written differently. So anything raised to the negative 1 power is no different than you being asked to divide the problem, or no different than if it all were underneath this one singular fraction. So what I'm going to end up doing is I'm just going to end up rewriting this. I'm going to write 3a here, and a 3a there, and a 3a there. And then I'm going to divide it. So 18 divided by 3, it's negative 18, so it's going to be negative 6. A to the third and a to the first make a squared, because 3 minus 1. And there are no b's, so we still have a b to the fourth. Minus 2/3 a squared, because we subtract again. And on this next one, the a to the negative 7th, remember from our previous video that anything to the negative power has to move from wherever it's located, which is also why this negative 1 ended up being on the bottom of the fraction. All the 3a's ended up being on the bottom of the fraction. This a to the negative 7 is going to move and jump ship down here, and when we move it, it's going to make a to the 8th on the bottom of the fraction, but we still have the b to the 5th on the top. So this is going to be 3a to the 8th power on the bottom. Okay? So that is kind of a review of the previous video we had. The new thing for today is going to be synthetic division. Synthetic division is different. It is way quicker than long division, which will be our next video. Long division. And it is quicker and easier. So synthetic division, what I always recommend is drawing this L-looking thing. And whatever you're dividing by, say we're dividing by the x minus 2, as long as you're dividing by x or a y or something like that, and then minus or plus a singular number, you can use synthetic division. All right, so we change the sign of this negative 2 to a positive 2. And then the numbers that belonged here, the 1, the negative 5, and the negative 3, end up going right here. Okay? If there were any missing terms, so for instance, if it goes from x to the third straight down to x, if you're missing the x squared term, or if you're missing the x term, or any term, you need to put a 0 for that. We're going to have that later on. All right, so here's how you do the synthetic division. Whatever the first number is, always just drops down. So that's going to be a 1. We end up multiplying the 2 and the 1 together to get 2. Then we add straight down. So we multiplied 2 times 1 to get 2. We add straight down. -5 and 2 make -3. Multiply 2 times -3. The process starts again. You get -6. Add straight down. -3 and -6 makes -9. These numbers right here are essentially your answers. But because we divided the x squared by a singular x, it is going to drop from x squared down to x to the first. -3, and then this would be technically x to the 0. So it goes like x to the first, no x's. The last number, this is what we call a remainder. And that remainder has a lot of importance that we are going to learn in detail later on. But for right now, what I recommend is you put a plus, and then because it's the remainder, over what we were dividing by, which was x minus 2. Okay? So the first time, synthetic division always looks a little scary, but then after a few more, you really start to get the hang of it. All right? So this one, number 4, is still synthetic division because we're still dividing by an x plus or a minus a number, in this case x plus 3. We have to change the sign of that 3 to -3. Then we put the numbers that are right here with the negatives, 2, 2, -4, and -12 in the right order if they happen to be out of order. Okay, they're not out of order, and we're not missing anything. It goes x to the third, x squared, x, no x's, so everything's there. Bring down the first number every single time. Multiply 2 and -3, you get -6. Add straight down. 2 and -6 makes -4. Multiply -3 and -4, you get 12. Add straight down. -4 and 12 makes 8. Multiply -3 and 8, and you get -24. Add straight down, you get -36. Okay? Last number is always your remainder. These numbers are essentially your answer, but you need to add the x's. So here we started with x to the third. It's going to be x squared. We drop by 1. -4x. We keep going down in order. If there's no plus or minus there, well, technically, if there's not a minus there, it is automatically a positive 8. So I put that as a +8. And then put the remainder. You can put plus the -36, or because it's negative, you can put minus the 36 over the original x plus 3. So that is our answer right there. Okay? Next problem, we got raised to the -1 power. Just because raised to the -1 power changes nothing. That is just another way to write divide. We have to change the sign of the 4. So it was -4, not having nothing to do with the raised to the -1. Now that -4 changes the sign, becomes +4. We have a 2. Be careful. See how we're missing that x squared term? So because it's missing, we need to put a 0 as a placeholder for that, then the -4, then the -3. Always be on the lookout. That is probably going to be the biggest mistake that you have for synthetic division. Bring the 2 down. Multiply 4 times 2, you get 8. Add straight down, still 8. Multiply 4 times 8, you get 32. Add straight down, you get 28. Multiply 4 times 28. I don't know what that is. 4 times 28 is 112. Add straight down, you get 109. Okay? So we started with x to the third, so this is going to be 2x squared plus 8x plus 28 plus the 109 all over x minus 4, because that is the remainder, and you divide the remainder by the original. Notice I did not change the sign of the original, and I decided to rewrite this one because I thought I was just going to run out of room. All right, last one for the basic synthetic divisions. Here we are missing quite a few terms. All right, so we have to change the sign of this 2 to a -2. We have an x to the fourth to begin with, and it's a -2x to the fourth. We are missing the x to the third, so that's a 0. Then we have the +12. So we went x to the fourth, 0x to the third, then the +12x squared, then the +3x. But we're also missing the last term, which is the regular number. We go from x to nothing. We need to put that nothing in for that, okay? So moving right along, we always bring the number down. -2. Multiply, we get 4. Add straight down, 4. Multiply, -8. Add straight down, 4. A lot of 4s. Multiply -8, add straight down, -5. Multiply the 2 and the 5, you get 10. Add straight down, you get 10. Okay? Feel free to go through that one yourself a little bit. Multiply and then add and multiply and add and see if you get the same thing as I did. We started with x to the 4th, so this is going to drop down to x to the 3rd. Anything that is already just positive, make sure you put that plus sign in between. Plus 4x squared, plus 4x, minus 5, and then the last number put a plus, and then over the original thing we were dividing by, which was x plus 2. Okay? Now, sometimes after we've gotten done with the synthetic division, the textbook, as well as myself, try and make things look a little bit more complicated. And they do in this like q of x plus r and d. All right, they throw in some random things. Sometimes you'll see some random stuff there. So q stands for quotient, which is pretty much what happens when you divide. R typically stands for remainder, but they could put any letter they have here. And d, denominator, I guess. All right, so this is no different. All we're going to be doing is dividing what we have. All right. We got a 4. We got quite a few missing terms because we go from x to the 4th. We're missing the x squared and the x to the 3rd. So when we do this division with the 8, we need a 0 for the x to the 3rd and a 0 for the x squared, then the -4, then the -3. Change the sign of this -2 to +2. Bring down the 8, multiply 16. Add straight down, 16 still. Multiply 32, add straight down, 32 still. Multiply 64, add straight down, we get 60. Multiply, we get 120. Add straight down, we get 117. Okay? So the quotient is this stuff right here, which would be 8x to the 3rd plus 16x squared plus the 32x plus the 60. That's the q of x. Okay? Then we always do plus the remainder. So it'd be plus 117 over the d of x, which is the x minus 2. So see how we have that? So this would be x minus 2. That is your r of x, and this is the d of x, the denominator. Okay? Or the divisor, you could even think of. All right? So it looks scary, but it's really just the exact same problem, written a little bit different. All right? These, however, are different. Find the values of the given variables. So we're expected to find a, and sometimes a and q, or a and b, or things like that. Okay? So try it the exact same way, and you're going to find that it actually kind of works out because we have some of our answers here. So we have a -5 on the outside. We have a 1, then a -1, then an a. Technically, it's a -a, so I'm going to write -a. All right? All right, well, what do we know that our answers should be? Well, we should know that our remainder, at least, is -20. All right, so let's fill that in, -20. We also know that if we add straight down, we could actually do a lot of this problem right now. 1 would drop down. And then if we multiply 1 and 5, we get -5. And if we add straight down, we get -6, which look here, 1x minus 6, 1x minus 6. So everything's working out so far. Well, what would be the next step? Well, the next step would be to multiply the 5 and the 6 together, the negatives, and we end up with a positive 30. Okay, well, this is the part that you would have to solve. We typically add straight down here, right? So that means that if we were to add -a and 30 together, it has to equal -20. So that means that we could solve this equation by subtracting the 30. -a would equal -50, and that must mean that a has to equal 50 if this is to work out. Not that bad. And we got our answer. If we plugged in 50 for a, minus 50, and 30 make -20. So it is true. Okay, so it worked out. Next one, a little bit harder, because we're missing the x squared term, for that matter, and it also has the a in a slightly different location. All right, but our remainder is still 20. That's convenient. So let's figure this one out. We got a positive 3 on the outside because we have to change the sign. We have a 1x to the 3rd. We have a 0x squared. We have a -a for the x, and then the -7. All right. our remainder is 20. Because right there, remainder. Let's do as much as we can. We got a 1 here. We multiply, we get 3. We add, we get 3. We multiply, we get 9. Now we have the tricky part because we have a 9 and an a here, which means that this spot right here, when we add straight down, is 9 plus negative a, or 9 minus a. Then we have to take this and multiply. Well, if we multiplied, this would be 3 times 9 minus a, which we could distribute. But at this point, I'm going to just write what we would have to do. Remember, we have to add straight down to equal 20. So that means that if we add negative 7 and 3 with the 9 minus a, that has to equal 20. Okay, no big deal. This is just a basic distribute and solve question. Negative 7 plus 27 minus 3a would equal 20. And then we get negative 7 and 27 makes 20 minus 3a equals 20. If we subtract the 20, you find out that negative 3a is equal to 0, which is kind of lame because that means that a is equal to 0. Okay? So no big deal because when you divide 0 by negative 3, you get 0. So a is equal to 0, but this one, it wanted us to find a and q of x. Well, q of x is almost found for because this whole stuff right here would be the quotient, and this is the remainder. So we have 1x squared. You don't need to write the 1. Plus 3x. And then the next part would be 9 minus a. So this would be plus 9 minus 0, which ends up being a q of x is equal to x squared plus 3x, not plus 0, but plus 9, because 9 minus 0 is 9. All right, that's going to do it for this one. Until next time, my friends, stay positive, and I will see y'all later. Bye.